All right, so today we're going to do graphs of rational functions. So remember the word rational is, comes from ratio. So that is a fraction, right? So a rational function is just your basic equation y equals 1 over x, or f of x equals 1 over x. So if you start plugging some numbers into there, something to note is you cannot plug in 0. You can't divide by 0. You can't put 0 on the bottom of a fraction because you can't divide by 0. So this part is undefined right here. But if you put a 1 underneath, 1 over 1 is 1. 1 over 2 is 1/2. 1 over 3 is 1/3. And I should do some smaller numbers too, something smaller than 1. So let's do something, because, 1 is 1, 2 is 1/2, 3 is 1/3. So you see this starts to get smaller and smaller, never 0, but it just starts to get smaller and smaller and smaller, approaching there. All right, so let's try a number like, 1/2. So if I put a 1/2 right here, what I would be doing is I would be putting 1 over 1/2. And so that would flip up and become 1 times 2 over 1. So that would become 2. So 1/2 turns into 2. And so if you do 1/3, that would be 3, and so forth. And so this part of the graph goes up there. All right. So basically, the other side of when you try a negative number produces the same answers except they're negative, right? So this would be -1, -1/2, and -1/3. And then if I did -1/2, I would get -2. Right? And so what it ends up doing is producing the exact same picture that you have, but it's down in the third quadrant. Okay, so this is just your basic rational function. Okay, your domain is all real numbers except for 0, so you can plug in 0, so it goes from -infinity to 0, not including 0, or you can go from 0 to infinity. Your range is the same thing. Notice that the answer was never 0. So this is called, you have basically a asymptotes. You've never heard of asymptotes before, but you get these kind of lines on your picture that you are going to stay away from, right? And so, let me see if I can get a dotted line. Oh, I forgot how to do a dotted line. There was a way, but nah. All right, so I'm just not going to. So you get what's called a vertical asymptote here at 0. So I'm drawing a dotted line because it's not really there. So this is a line, x equals 0. This is a vertical asymptote. This is a vertical asymptote, okay? And then you also have an asymptote going across that your graph stays away from, and that one is called a horizontal asymptote of y equals 0. So that word right there is asymptote. All right, and you have a vertical and a horizontal. Now, a vertical asymptote is what your x values will never be, and a horizontal asymptote is it's kind of like what your y values will never be, but it has a little bit more of a different meaning when we get down to it down here. So your range in this picture, everything except for 0. Because you didn't touch 0, a y value of 0. All right, maxes and mins, none. All right, nothing stands out as a high point or low point. There's no x-intercept or y-intercept. So when this graph moves around, left, right, up, down, then, some of these things start to happen. Increasing intervals. Let's follow this graph. So this graph, it starts kind of like higher and then it goes down. Here it starts higher and it goes down. So this graph is always decreasing. So it's decreasing from -infinity to 0, and then after 0 on. Now, this would change if this graph was like flipped over, right? Like if you had a negative here, then and everything would be increasing instead of decreasing. All right. Constant intervals, none, and end behavior. So your end behavior. as you go to negative infinity, so as you go to negative infinity, this thing creeps up towards your horizontal asymptote, and this creeps down towards your horizontal asymptote. So what your horizontal asymptote is doing is it's telling you that your end behavior, so 0 and 0. So basically, anytime you have a horizontal asymptote, that's also going to be your end behavior. Whereas before you had to look and see if it, like with polynomials, it was always like infinity or negative infinity. Now it can be a number. It can also be positive or negative infinity here, but most of the times it's a number. All right, so let's talk about this graph if you want to move it left or right. So just like before, let's say we have something like x minus 2. So x minus 2, what that's going to do is it's going to take this picture right here, and it's going to take everything and move it to the right too, just like it has with our other pictures. So our vertical asymptote is going to move over. My horizontal asymptote is not going to change, so I'm going to draw those first. So and then the graph will just sit right inside there. Okay, I'm not drawing them super accurately, but all right. So let's do another one. Let's do y equals, and let's put a negative inside here, and then put 1 over x minus 2. So that negative would basically flip your graph over, right? It would flip it like that. Okay, just to take care of that. Oh, I guess I have that over here. We'll do it again there. All right, up or down. So when you have a horizontal a movement of up or down, there's a couple of different ways you can do it. And let's say I have this, and I put something like you know, a plus 3 over here. Okay, so then you can see, oh, I'm moving this graph up 3. So this is one way to write it, and then you definitely know that the graph has been moved up 3. So 1, 2, 3. So that your horizontal asymptote is there, but then your vertical is still there. And so this graph is going to sit right in here. Okay, now something to note and to talk about is how to find your x-intercept and your y-intercept, right? To find your x-intercept, you want to plug in 0 for y. So you want to let this be 0, and you have 1 over x plus 3, and then you're going to go ahead and solve that for x. So I would take away 3 from both sides, so I'd get negative 3 equals 1 over x. Cross multiply, I'd get negative 3x equals 1, and so x equals negative 1/3. And so you can see that crossing right there at negative 1/3. Now, I still can't let x be 0 because there is no y-intercept because there's my asymptote right there. But so, all right, so this is one way, and you can notice here that your horizontal asymptote is now y equals 3. Your vertical asymptote is 0. Over here, you had x equals 2, and then y equals 0. Okay. All right, reflection. I guess we already took care of that, so I'll just skip that. Vertical dilation or a stretch. So that would be like if you had something where you multiplied by, let's say, 3. Let's say you had 3 over x. So you can't really see it that well. Like in this one right here, if I do 3 over x, I can't let x be 0. So that's my vertical asymptote. And my horizontal asymptote, in this case, you'll learn why in a second on the next page, is also going to be 0. All right, and then what's going to happen, because it's basically just a multiple of this part right here. So what's going to happen is everything's going to get higher faster, right? Like remember how the point right here used to be like 1, 1? So now this is going to be 1, 3, right? And so that's going to be 1, 3. So that's going to like, it's just going to shoot up faster and then go down there faster. So you won't really see it that much. It's just going to basically rise sooner. And then if it's a vertical dilation but a shrink, so that means that your multiple is like, let's say you had multiplying by 1/2, so like 1 over 2x. And so then what you're going to see there, instead of 1, 1, it'll be like 1 and then 1/2, right? And so that'll just get like pulled down, right? It'll get closer to the ground, or closer to the axes. And so you don't really need to like draw them that perfectly or anything like that. This still has vertical asymptote, a horizontal asymptote and vertical asymptote. Okay. All right. So usually you will not see your problems written like this, right? And so you won't see them, if you wanted to have a horizontal motion and a vertical motion together, then you would have something like, you could have y equals, let's say, 1 over x plus 3 and then minus 2. So then you would know that this graph has been moved to the left 3 and then down 2. And so if you're going to move that left 3, then you know your vertical asymptote is going to be here and down 2, and there's your horizontal asymptote. And your graph would be fitting like right inside there. Now, usually your graph is not going to be in this format. So let's talk about how it's going to be on the next page. So your vertical asymptote, these are the rules for that. What you're going to do, a vertical asymptote is going to occur for any value that makes the denominator 0. Okay? And I'm going to say except if there's a cancellation. All right, so I'll show you that down here in a second. All right, a horizontal asymptote. Horizontal asymptote has 3 rules. Okay? Rule number 1. And I'm going to be talking about the degree of the numerator and the degree of the denominator. So look at these problems here, like here. The degree of this polynomial up here is first power. The degree of the polynomial on the bottom is a second power. So the degree of the numerator is 1, the degree of the denominator is 2. Whereas over here, the degree is 1 and 1. And over here, the degree up here is 0, the degree down here is 1. All right, so when I say degree of numerator, if the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote is y equals 0. Okay. If your degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is an equation that takes y equals, and what you're going to do is you're going to put the leading coefficient of the numerator and divide it by the leading coefficient of the denominator, which you'll see down here. But what I mean by that is this. Let's take a look at this problem. Okay, let's take a look at this one. These x's, they match. So the leading coefficient of the numerator is -2, and the leading coefficient of the denominator is 1. So I would take -2 and put it over 1, and that would be my horizontal asymptote. Okay. All right, and the third rule is when your degree of your numerator is bigger than the degree of the denominator. You have no horizontal asymptote in this case. You have something called a slant asymptote. And you would need to do long division to figure out what that was, but we're not going to cover that here. Okay, so for an x-intercept, remember, an x-intercept is when the y value is 0. So ask yourself, you have y equals, you have a fraction, some kind of expression over another expression. When does a fraction equal 0? So a fraction equals 0 when the numerator equals 0. So if you ever want to know the x-intercepts, you have to check and see when the numerator of your expression is equal to 0. Y-intercept is when x is 0. So this one's very easy. You just plug in 0 for all the x's. Okay. All right, now a hole. A hole is going to occur in a graph. It can occur, and it's going to happen, I think, if I remember right, in this last one down here. But a hole is going to happen when you have a problem that has a common expression in the numerator and the denominator. Like, let's say like our problem is all factored, and I have like x plus 2 and x minus 1, and then I have x plus 3 and x minus 1. So you notice that these cancel, correct? So normally you would have said, oh, hey, there's going to be an asymptote, a vertical asymptote at -3, because -3 is when the bottom equals 0, and also at +1, because that's when the bottom equals 0 as well. But little did you know, this cancels. So that you lose it as an asymptote is still an issue, but it's not an asymptote anymore. It's just a hole. So there would be a hole at x equals 1. And so it'd be 1 comma. And to get the answer for the whole, what you do is you plug that number back into the problems that you have in the equation. So 1 plus 2 on top is 3, and 1 plus 3 on the bottom is 4, so 3/4. And I'll show you on the last example how you would deal with that. Okay, so a whole is going to occur whenever there's some kind of common factor in the numerator and the denominator that cancels out. All right, so let's put it all together here in our last little bit. Yeah. All right, so let's see. So let's use our rules. What makes a vertical asymptote? What makes the denominator 0? So my vertical asymptote is going to be x equals 2, because 2 minus 2 would be 0. My horizontal asymptote, I look at my rule. The degree on the top is 0. The degree on the bottom is 1, because x are the firsts on the bottom. So that means my degree on top is smaller than the bottom, so that means I'm going to be using this right here. So my horizontal asymptote is y equals 0. So let's draw those on there. X equals 2, y equals 0. And I notice that there's no reflection, so this graph is going to be kind of like the normal graph we started with at the very beginning of the video. All right, and let's find a couple other important things. Let's find any kind of x-intercept. So x-intercept is when the y value is equal to 0. So when does the y value equal 0? So I want to set this thing equal to 0. So the top of the fraction would have to equal 0, just like we set up here, right? And 5 is not going to equal 0. So this one does not have an x-intercept. But a y-intercept occurs when the x value is 0. So if I let x be 0, so if I let this number right here be 0, I get 5 over negative 2. So 5 over negative 2, that's negative 2.5. So 0 and negative 2.5 is right there. All right, so now I can just go ahead and draw my picture for the rest. And this one's just going to be up here. Okay, and of course you can go and Desmos your calculator and get like perfect points and whatnot. All right, so let's talk about here this next one. What makes the denominator equal 0? That's my vertical asymptote. So x can't be negative 3. That's also my domain. So x equals negative 3 is my vertical asymptote. My horizontal asymptote, my numerator and denominator have the same degree, has x to the first in both. So I take the leading coefficient, negative 2, over the leading coefficient of 1. So y equals negative 2. All right, so let's draw those on there. X equals negative 3. All right. So then I have let's see. I want my x-intercept is when y value is equal to 0. So I want to know when does this equal 0. So this equals 0 when the numerator equals 0. So it's going to happen at 0, right? 2 times 0 is 0. And so that's also technically going to be a y-intercept as well. And so I would also be able to tell that, you know, when I plug 0 in here and here, I get 0 over 3, which is also 0. So basically, I have an x and a y-intercept in one shot. All right, so across at 0, 0. And then that kind of helps me to realize that my graph is up top here. All right. Oh, but there's a negative there. Let me make sure of something here. So negative 2x over x plus 3. Let's go ahead and 2x over x plus 3. Okay, I was just checking this out, make sure everything is good. It's fine. Okay, so let's see over here. So basically I was making sure that negative sign didn't create a reflection. And since as I went through 0, 0 here, I kind of knew the graph was up there. But I just checking it out. So basically also what you can do is you can do some test points, right? Like if you put a number in like 1. So if I put a 1 in here, I get negative 2 over 1 plus 3, that's 4, so negative 1/2. So, you know, I'd able to tell the graph was like right there. So I was just making sure it wasn't supposed to be like here, but it wasn't. Okay, so on this next one, now, in the denominator, I need to factor this. Everything has to be factored to be able to tell what you're looking at. So x plus 2 and x minus 2, this factors into. And the top is 3x plus 1. Okay, so I have two numbers that the bottom would become 0 at. So I have two vertical asymptotes. One of them is at -2 and one of them is at +2. My horizontal asymptote, the numerator on the top is 1, and the numerator on the bottom is 2. So y equals 0 is my horizontal asymptote. If I was going to do my x and y intercepts, if I let y be 0, that would be my x-intercept. So I have to imagine when is this equal to 0. So when is 3x plus 1 equal to 0? That would be a -1/3. And when I let all the x's be 0, so if I let this x be 0 and that x be 0, you see how I have a 1 over -4. So I have a -1/4. All right, so let's graph this up. Y equals 0. X equals -2, +2. And I can also mark on here -1/3, 0. So you notice that's right on the horizontal asymptote. You can touch horizontal asymptotes, but you cannot touch vertical asymptotes. So it's okay to cross a horizontal asymptote. It just tells you what your graph is going to be at, towards infinity and negative infinity. And 0, -1/4, right there. All right, so we need to put this in the calculator, or the Desmos. 3x plus 1, x squared minus 4. X plus 1, x squared minus 4. All right, so notice that the outer two parts kind of act like we're used to, and I have like what looks kind of like a cubic function in the middle a little bit. Okay, so we're just like sketching this. This guy's over here, this one's over here, and this one is going there. Okay. All right, on this last problem here, when I factor this, I notice that I have x plus 5 and x minus 3 when I factor that. And these cancel. So that means that there's going to be a hole in the graph, a hole at -5. Because -5 is the number where I would have had an asymptote, but it's no longer there. So when I cancel this, notice this becomes 1 over x minus 3. So if you plug -5 in for x here, you get 1 over -5 minus 3. So I get -8. So I get -1/8. So -5 and -1/8 is going to be a little teeny tiny hole. A little hole right there. Okay. All right, so let's go ahead and do our asymptotes. So I have a vertical asymptote still at 3, all right here. So x equals 3. I have a horizontal asymptote. Now, you can look for a horizontal asymptote at the beginning or later. Either way, the numerator has a smaller degree than the denominator. And here, remember, the numerator has a degree of 0 and this has a degree of 1. So either way, you're going to say y equals 0. What's it called? An x-intercept. Well, what makes the numerator here equal 0? Nothing, because it's 1. So there's no x-intercept. And when I plug in 0 for x, I get -1/3. So I can go ahead and mark that. -1/3. All right, so let's do my asymptotes. X equals 3. Y equals 0. So what you're going to see here is the graph is going to come across here and come down, and then the graph is going to be up top here. All right, we're going to go ahead and put this in on Desmos. And so when you see it here, it looks like a normal problem, right? But just be careful. If you zoom in and zoom in on -5, so if I hold this down, usually I can drag it here. There it goes. So look what happens at -5. Oh, right there, you saw it? -5 actually doesn't have an answer. So you can't really tell it on the picture, but basically if you look at what this looks like, this is what our picture should look like. It should have an open circle here because there's nothing there, right? So, but you're not, Desmos isn't going to show it to you. You kind of have to like know it's there. Okay. All right. And that is it.